Hello, hello, Shagat Unknown here. Welcome back to another Rust coding stream. As I forgot to mute this. Um, Welcome back to a scuffed Rust coding stream here on the 21st of September 2022, local time 17:21. And I actually wanted to start off a little bit different here. What we're going to do though today, we're going to be picking up with the roguelike tutorial I've been doing. We're going to attempt to finish this off. So that's going to be 5 parts. It's going to be maybe a little lengthy there, but we have spells and ranged combat. We have main menu and saving. We have dungeon levels and character progression. We have monster and item progression, and we have adventure gear. So we're going to try to run through all those, and I wish I would stop getting notifications. Let me mute them. Yes, mute. There. You have this problem with the way the notifications work that you have to get multiple before it lets you mute it. So it's like, stop doing that right when I start streaming. Because even though I've like muted the phone, they're still popping up. Alrighty. So anyway, I was kind of rambling off these as endless notifications were coming in. I want to start off with something a little different. This is a terrible start. But I do want to start off with something a little bit different to give us some extra context, or maybe, we'll see how this goes. But I had an idea here. So I was thinking about this, I don't know if it was last night or the night before when I did the last coding stream, but I was thinking about it. And I feel like sometimes you lose context when you're going through these tutorials, because what you do, and I'm not saying that the tutorial is written poorly, but what I'm saying is that a lot of times it's very easy to just follow down the line of a tutorial and maybe lose a little bit of context for why some things are happening or how you arrive at a certain solution. So it can feel a little bit like magic because somebody else has already done all the thinking about, well, why did we do our map this way, right? So you didn't really do the problem solving part of like building the map or deciding, how are we going to link rooms together? Well, we could go over and up. We didn't do that problem solving, right? The tutorial kind of did that for us. And again, that's not to say it's a bad tutorial, but I was thinking about that, and I thought maybe I wanted to take a quick little moment here, at risk of making this last session here run even longer, but I would like to take a quick little moment here at the beginning to talk about this function here and give some motivation behind it. So this is a weird one we ran across, and I feel like this is easy to not fully appreciate what's going on or why you need it, because what we're really trying to do is we're trying to get 2 separate things from a given slice. So if we have like a vector or whatever, and we want to get 2 mutable references to like 2 different things within that vector, we have to do a little bit of work to do that. And we didn't really get that full motivation because the tutorial, again, not saying it's bad, but basically the tutorial is like, hey, if you try this, you're going to run into problems, so here's the solution. And they do explain the code, but we didn't really get that problem solving aspect of what it's actually like to run across something like that. So I was thinking, I might take a moment here to just, do that. And this isn't scripted or planned or anything. I didn't study that function or anything, but I kind of get the idea of what's going on. So maybe we could do that real quick and see where it goes, just to give an example of like, okay, this is some of the motivation, this provides context. And then hopefully that, being done here at the beginning can kind of set the stage for the rest of the tutorial that'll be wrapped up today, and really put us in the right frame of mind to try to think of everything contextually rather than, oh, the tutorial said to do this, so we just do it. Again, there's still going to be some of that where we can't go through every single bit of like problem solving, but at least to get that in your mind, that when you're doing a tutorial like this, you should also, try to have it somewhere in there of how did we reach the point that we're at, right? So let's try this here and see what happens. Like why not? What's the worst that could happen, right? I mean, I could run into some issue and everything just breaks, and it is what it is though, right? Not scripted or planned or anything. So we're gonna try making a mutable vector called just test pattern. and it's going to be a vector of, it doesn't matter. It can be a vector of, number, it's almost too easy, but we'll do 0, 1, 2, 3, 4, 5. Actually, I like this. I like this because I can get two mutable references to like two different things and then increment them and then like print this vector out, and we can actually see how it looks both before and after the like before and after making the changes. So the first thing I want to do is let's go ahead and print it out. No, you didn't, Tusk. I really don't like, that's a bit too much for like the coding streams though. It's like, that's why I'm not addressing that. It's a bit too off topic. So we're gonna go ahead and print that. That's all I'm really gonna say on that. All right. So now what I want to do is like, let's actually try to do this. So we'll say let ref 1, and we'll say, actually, do I want to make them variables? Yeah, we'll say ref target 1 equal, and then we'll say this is like index 4. And then we'll say ref target 2 is like index 7. So I just want to make those variables so it's a little bit more like passing them into a function, although I know that also just adds more to what we're dealing with here. So then we'll say let ref 1 equal, and it's going to be test pattern 4, a reference to that, and then we'll do ref 2. Oh, why did I shouldn't be 4, I should use the ref target, my bad. Ref target 2 and ref target 1, but I want to say let mute, and so it's actually not complaining at the moment. Let's see. Now I'm curious why. See, this is not scripted, so we'll see what happens. Remove this mute, remove this mute. No, but I want them to be mutable. So let's try to get these two out of here. And we'll go ahead and copy and print test pattern. And we'll say ref, we'll dereference it, and we'll do plus equal 1 on it. And we'll do that with number 2 as well. Here we are. Okay. Cannot assign to that. So the data it refers to. Cannot borrow as immutable. Hold on. See, we're getting somewhere now. Cannot be dereferenced. Okay. You're letting me reference both of those, but I'm a little concerned why you're going to let me do that. So let's run it and see what happens. Oh, I'm in the menu. Oops. I thought I was in main. Didn't pay enough attention. All right, we should put it there. So it's going to let me run it. But 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're not actually getting the references like I wanted. So that's the problem. I think what I initially was trying to do was fine. So we have references now, and I want to dereference and modify them. It's behind an ampersand reference, so the data it refers to cannot be written. Okay, so these are not actually mutable references like I want. So what if I do get mute? We'll have to do it with the index like this. Ref target 1. We'll have to do it that way. I was trying to shortcut it a little bit. And we'll just unwrap. There we go. That should do the trick. And get mute ref target 2 unwrap go. So yeah, we can't do it mutable more than once at a time, right? So we could try to change them. It's not going to be happy if we do that. This is the motivation behind why we make the mute to function that we talked about before. So the thing is, when you run across code like this and you're like, ooh, I need to get 2 different things out of this vector, whatever you're doing, and you run into something like that, we see it's complaining that, yeah, can't borrow test pattern as mutable more than once at a time. And it's showing me exactly where it's happening on both occasions, right? First borrow occurs here, second borrow occurs here. So this is where your motivation comes from to build out a function like that, like we were talking about. Well, like we actually did in the tutorial. But what I want to do now is kind of show how you go about a little bit of that problem solving. And some of this does require a little bit of prior knowledge in, well, not require, but it requires the ability to go look at, like, what are some of the options you can do with like a vector or a slice or whatever, because you need to be able to go into the documentation and figure out some of your options, basically, if you don't already know them. So if I look at test pattern, there should be that we could do like splits, and we could do split at mute. So this is like really the one that we want, because, and this is what we used before, and it just divides one mutable slice into 2 at an index. And then it tells us everything we need to know. The first contains everything from 0 to mid, excluding mid, and the second contains mid all the way to the end. So that's what we need that gets us that. And if you don't know that initially, you kind of have to look at in the documentation and see, what do vectors have, right? And then you find out, oh, vectors have this split at mute thing. Maybe you find that, or maybe you Google around a little bit. I mean, I can't give much of a better answer to like how you initially find this, other than that someone has probably done it before, so Stack Overflow exists and everything. And there we go, we end up with some information. So we can do split at mute, which we already have used before in that other function. But again, we didn't go about this in a bit of a problem solving kind of way. So split at mute is going to split at that midpoint. So we need to be able to figure out what the midpoint is. Now, this is something we did in the code already in that function, but we need to like figure out how to do that. Also, I know that split at mute is going to give me 2 things back in the form of a tuple. So we're going to say, we'll say split 1 and split 2. Just as some variable names there. And then what we want to do is we want to figure out what this mid value is, and then we'll use that to get the 2 refs that we actually want. So to keep this from complaining, let's go ahead and now figure out what mid equals. So we need to do a little bit of like code here to figure out which one, or how we assign this value mid. And basically it's all about like reading and really understanding how this works and how mid is used. So again, mid, the second split that we get here is actually mid to the end. So all we really care about is that mid is like the larger of the 2 values that we're trying to use here, basically. And then that will guarantee that it's on the second half and the first one's on the first half, right? So that sound maybe a little strange, but it works. So we, instead of actually making a little bit of code there, what I can do is just say std compare, and we say max of ref target 1 and ref target 2. So this is our midpoint. And now we split there, and we can actually get the 2 refs from the splits that we have, basically. So I could say split 1 and split 2. But then there's a little bit of another gotcha that's going on here, because what's happening is we don't know which order the split happened in, right? So we do need to make a quick decision before we go about doing this. And there are cleaner ways to do it. Actually, no. We'll just say, we'll just declare ref1 and ref2, and we're not going to initialize them yet. So we'll just go ahead and declare them. There are still cleaner ways to do this, but I just want to show how you could go about figuring this out. So then we'll just say if ref target 1 is greater than ref target 2. Now, our function had an assert in it that says they can't be the same. We're leaving out a little bit of that here, but the what's the word I want to use? What is the word I want to use? The sentiment still stands. So ref1 is we're going to say it's always from split 1, and ref2 is going to be from split 2, but it depends on, well, I don't know. Let me think about this. So whichever one is larger. So if ref1 is larger, no, okay, no, we're gonna preserve the order. Yeah. So if ref target 1 is larger, then that actually says that, and this would be ref target 2, I believe. Else we flip them. So let me explain how I came up with these numbers, and then we'll pretty much wrap up this little exercise here. But I hope this is helpful a little bit in at least trying to explain how you do some of this problem solving and how you like reach that motivation. And then we don't need to deref. Okay. Oh wait, actually I need to do .get mute at 0. I need to replace those. I'm going to do get. And we'll do unwrap. There are, you know, still other ways and better ways to do it, honestly, but it's good enough to get the idea out there, right? Whoops. So we need that there, and it's getting bad. Okay. There were other ways to have done that. Error, binary assignment cannot be applied. So yeah, now we have to deref. We actually have references, and there we go. So now if I did this right, we have two mutable references to two different parts of test pattern, and we're going to be able to change and mutate both of those. So what we see, 0, 1, 2, 3, 5, 5, 6, 8, 8, 9, 10. So we were allowed, actually it's kind of being blocked, but it's down here. We were allowed to do the double mutate just as we expected. Normally, and yeah, this technically doesn't have to be mutable because it's a mutable reference. So it's this weird thing where this is one of the things that I think is a slight confusion in Rust. So the type of the variable is a mutable reference to an I32. So if we're dereferencing that variable, the I32 in there is mutable, but we're not actually changing ref1. So technically it doesn't have to be mutable and we still achieve the effect. It's a weird thing you can come across that I think can take a little bit to grasp. But the idea is here, we've done what I set out to do. It didn't take terribly long, although it took a little bit. But the idea here was to show how you would start with this problem. And in this case, we're modifying a couple numbers in a vector. It's not that crazy. But in the case of what we had before, it was two objects in our game, in our list of objects for the entire game. So it was two objects, and they needed to be able to like interact and fight each other. So we needed to be able to have that double mutable access because they're taking damage and stuff, right? So we needed to be able to have that access to like both of them, and really, you know, kind of not defeat the Boro checker, but like really satisfy the Boro checker. We're not defeating it because it's still here. We've just basically proven by using split and mute, we're proving like, hey, these two things are separate now, so we're allowed to use them separately, but we're still referencing into the same overall vector test pattern, which I made up here. So it's a bit of a detour, but the idea is that this provides context of how you start from, or how you like run into a problem like this and how you might go about solving it and figuring out, you know, well, how do we make it happy? You know, it's mad at me. How do we make it happy? Right? And it's to show like, if you ran into this problem while you were making the roguelike up to this point, and you didn't have a tutorial just telling you, here's the thing to do, right? That's the real point. So I want to have that context in the back of my head for the rest of this, and I hope you would as well, where we want to think about everything that shows up in the tutorial as a like, even if we're not going to explicitly go over it, how did we get to that point, right? What could we have done differently? So we decided to do just straight lines to connect the rooms, but what might we have done differently there? Always be considering that, or always consider maybe how the solution was arrived at, rather than just here's a solution, because that's how you become a better programmer. That's how you become a good computer scientist in general, if that's more of what you're interested in, more than just programming. By simply finding a solution and writing it down, you're not really learning anything. You need to be able to break that solution apart and understand what led up to it. There are jokes, I should say, however, about programmers, software engineers being glorified Googlers who just go and copy paste code. And, you know, I mean, there may be some truth to that for a lot of people. But the point is, if you want to be good at what you do, if you want to actually seriously, you know, sit down and do something like make a game, you need to try to understand what led to these things and the motivation behind them, and really be able to like break it apart and pick it apart, right? That's the point. So I think I've driven that home enough now. So let me get a drink. Let me read this that popped up a minute ago in the chat, and then we'll get on with the tutorial. So I did see this pop up, but I was trying to, you know, stick to a train of thought. You know, you say that. I agree. The joke is about don't shoot, I'm a programmer. Prove it. Arrays start at 1. No, you know, that's a thing, like most of the time they do start at 0, right? But languages like MATLAB, they start at 1. And I think the idea behind it with MATLAB was that it was going to be easier for like just standard like non-programmers to read, but like programmers hate that, right? Because every other language, you know, C, C++, Rust, Java, Python, like everything starts at 0, and then you got a few weird oddballs. You know, there's MATLAB, like, hey, what if arrays started at 1? But no, go away. So yes, you say they're triggered from hearing that. Yes, I am triggered. I am right now, not just the guy in the joke, but I am. Alrighty, so let's get on with the tutorial now, because we're probably going to be here for 4 to 5 more hours. So let's not waste any more time. So let's start with, what is this, 9? Yeah, part 9, spells and ranged combat. The inventory we implemented has lots of untapped potential. I encourage you to explore it fully and create as many different items as possible, though the special category of items that can be equipped like swords and armor will be done in a later section. To get the ball rolling, we'll start with some magic scrolls the player can use to cast spells. We'll sample a few different spell types. I'm sure you can then create tons of variants from these little examples. Magic scrolls, the lightning bolts. The first spell is a lightning bolt that damages the nearest enemy. It's simple to code because it doesn't involve any targeting. On the other hand, it creates some interesting tactical challenges. If the nearest enemy is not the one you want to hit, for example, it's too weak to waste a spell on it, you have to maneuver into a good position. Just modify the place objects function to choose at random between a healing potion and a lightning bolt scroll, the same way it's done with monsters. Yeah, so we're just not even targeting, which is interesting. But that actually makes sense because lightning bolts are pretty unpredictable. So I think we're also going to do like a fireball or something that's a little bit more predictable and we can control it. So we're going to go to the place objects. And where is the potion? So we have the healing potion here. And what we're basically going to do is instead of saying create a healing potion, we're going to do some random stuff here. So we're going to say let dice equal random. So even right now, you should be thinking about like why I'm writing any of the lines that I'm writing. Why are we doing this? Because we want to randomly choose which item we're distributing into the rooms as we generate the rooms, right? So what we're going to say is there's a 70% chance to make the healing potion. So we'll go ahead and do this here. We'll just bring it up in here. I think that should be everything. Except we're going to then say object. Basically, we are feeding object out of that. If else may have incompatible types. Yeah, that's okay. We're dealing with it. So else we'll create a lightning bolt. 30% chance. And that's because if it's not 70, if the other one's 70, then this is just a fallback, right? Simple enough. Right, so we're going to make this thing position's fine. It's the same thing as the healing one. Basically, everything's the same. We're given a different color and a different name. That's all that's changed. So it's not super special how we're doing this. It's only the randomness that actually changed. Now, this is new because we need a new variant here for the object, like the item field. We need a new variant, so we'll create that in a moment. And then we'll push item into that, and we also need to put this semicolon here because this semicolon is actually the end of this giant let statement. Let item equal, and then we have an if else. So both the if and the else block have to return an object, and then that gets spat back out to item, and then everything is happy. So generate variant lightning. Boom. I did it without even looking at it. So let's go back to the tutorial. This means we have to add a new variant to the item enum lightning, and we need to add a new onUse variant to the use item. The compiler will complain if we don't, so let's do that. So yeah, we'll add that match there. It's already going to be red, so it'll lead us back there real quick, and then we'll write a cast lightning function to go along with that as well. So let's go ahead and take a look at this. I see some red down here, so that must be it. Match item, yep. So now we need the lightning variant, and it's called cast lightning. And then wherever I did cast heal, which I was going to say is probably down there. So now we need to do cast lightning. And it takes inventory ID. I still don't know why we're passing some of these in if we're not using them. You know what it might be? That other functions may actually use them. So we are using these as placeholders for other functions in the future. One thing I'm really looking forward to with the next roguelike tutorial I'm going to do that looks way more in-depth is they actually have a section on the design document. And I think that could be very helpful to really break down what you're doing ahead of time. Again, I don't want to say anything necessarily bad about this tutorial, but sometimes it feels like, oh, we're just kind of throwing things in. And it's really fun and exciting when you're doing this for the first time. But you miss out on some of the context of why we're making the decisions that we are, kind of what I talked about already. So if you have a design document that says this is what the game should be doing, then a lot of these things make sense, and a lot of these things actually fall into place before you really start working on them. So before I make the first function, which was cast heal, we would already say, oh, well, anytime we use an item, we're going to need these things, because our design documents kind of spelled out how items work, right? Now, design documents can be very, very in-depth and not the most fun thing to make, but they are critical in like large-scale game development in order to keep the entire project and team or whatever focused. Otherwise, it's too easy for like scope creep to happen, and oh, but what if we do this? What if we do that? What if we do that? And the project will never be finished, right? All right, so what are we doing with this here? If let some monster ID. Okay, so we need a new function for closest monster. We're going to be making that in a moment, I guess. Yeah, and that's going to give us back an option. Okay, cool. So I was like, how is this if let going to work? So yeah, we'll see it soon enough. And see, that's another thing. We need to ask these questions as we're doing this. Even though the tutorial does end up spelling it out, I'm asking myself as I'm writing that, why do we have an if let? What is monster ID? A lightning bolt strikes the blank with a loud thunder. I think that should be a new line. We'll try that. The damage is blank hit points. The way they have it written is a little odd. So objects, monster ID, name, lightning, range. Oh, damage. Okay, so we got a big old message here. And light blue. Should be in here. Right. Let's see. That's the format. Yeah. So why is it mad? Because I don't have... Oh, it's still looking for the use result. We'll get there in a moment. Okay. Okay, so we do all that fun stuff. And then we do object monster ID dot take damage, lightning damage, game. Yep, still no lightning damage. Monster ID is kind of, I think we've already kind of, not really. I was gonna say, I think it should have figured out what monster ID is if we're using it as a index here, but it doesn't seem to have figured it out quite yet. Use result, used up, else, no enemy found within the maximum range. I really don't like using this add one that, I mean, it works, but it feels kind of cumbersome with the format, which we're not doing this time for some reason. Oh yeah, because we don't need an we don't need a parameter. All right, so we cancel, and it still hasn't figured out what is inside the option here, but we'll break it down soon enough. So it's a plain spell, but an imaginative message can always give it some flavor. It returns uses the okay, that's weird. It returns the used result canceled if canceled to prevent the item from being destroyed in that case, like the healing potion. There are also a couple of new constants that had to be defined. I feel like they left out a bit here, but basically, if it's not used, if there are no enemies, then it returns canceled. If we do use it, the monster takes damage and we return used up. Okay. And then we need some constants. We need damage and range. And I don't really like to copy paste too much, but I am going to be lazy on this one and just copy paste it because why not? It's pretty simple. Just a couple quick constants there. Ideally, I would probably not want to put that as a constant. I would probably want to tie it to the item or something. I feel like that's a little more extensible over time. So the next thing is we're going to need to write this closest monster function. So it'll stop complaining here. So we can find closest enemy up to max range and in the player's FOV. You know what I think could be interesting is that lightning could target something out of the FOV, perhaps. I mean, that's something that would be left up as an exercise, I guess, but lightning kind of has a mind of its own. And I don't like the idea that if something's out of your max range, but is still in the range of the, it's out of your FOV, but still within the max range, that it would just stop working because you can't see it. All right, so closest enemy is none. All right, so yeah, this is actually a clever trick that I can already see what we're doing. This is the kind of thing you use all the time, where if you want to find like a minimum value, you actually start with a large value, and then you check to see, is this thing smaller? Then that's our new min. Is this thing smaller? That's our new min. Is this thing smaller? That's our new min. Or vice versa for max. If you want to find a large value, you start with a really small value or like a negative value or something, and you just check to see if the thing is larger than your current value. If so, assign it. We're going to be doing that here. I can already tell without reading ahead. We want the closest distance, but we're going to start with more than the max range because it is possible that the closest distance is at max range. But in order to make sure we actually find something, that's why we initialize it here with more than max. So for ID object in object.iter.enumerate. So if the ID is not player and object.fighter. Why are you mad? Hold on. If ID not equal player and object dot fighter? I'm wondering why it's not auto-completing that. Objects.iter.enumerate. It's unknown for some reason, but we know what objects is. Oh, I typed an S on that. Yeah, okay. Now we're happy. There we go. See, that threw me off. That is some. Okay, so if it's a fighter and it has AI and it's not the player and tcod.fov.is in FOV object.x and object.y. Whoops. Then we calculate the distance between the player, this object, and the player. So distance to object. If dist is less than closest dist, then we update closest dist, basically, and the ID, the index. So it's closer, so remember it. Go. All right, so yeah, let's break it down one more time. Actually, no, they're going to talk about it here, so let's just read how it works here. All right, we need to loop through all the monsters and keep track of the closest one so far and its distance. By initializing that distance at a bit more than the max range, any monster farther away is rejected. We also check that it's in FOV, so the player can't cast a spell through walls. See, that would be the trick. You don't want to go through walls, but what if you could go like around the, what if it arced a little bit around the corner? Lightning is weird, right? Lightning attracts to things. So I think you could do some interesting logic with that. This makes use of the distance to method we wrote earlier for the AI. All right, the lightning bolt's done. If you have one, you can take down a troll with a single hit, sparing you from a lot of damage. So what was cool is we didn't actually do that much, but apparently now we have a working lightning bolt. And what's wrong with where's that at? This actually needs tcod. Okay, so what do we have here? We could get a couple things, some healing potions. Come on, I need a lightning bolt. I want to start bopping on some dudes. They only have a 30% chance, right? So gotta keep that in mind. We're getting a lot of healing potions, though. I'm gonna use a bunch of them real quick. Stay alive. Oh, I died. Okay. Not staying alive. Where is my lightning bolt? We got a funky thing going on here. And no lightning bolt. Oh my god. And taking that damage. That's for show. It's like any time now. Starting to think something's broken. There's one, but I'm almost dead. Let's use it in a last-ditch effort. Orc is dead. Okay. We hit him for 40 points. It is what you expect. I am barely alive, but we're good. That's all I wanted to do is see it in action. So let's go ahead and keep moving. Spells that manipulate monsters. Confusion. There are many direct damage variants of the lightning bolt spell, so we'll move on to a different sort of spell, one that affects the monster's actions. This can be done by replacing their AI with a different one. That makes it do something different, run away in fear, stay knocked out for a few turns, even fight on the player's side for a while. My choice was a confusion spell. That makes the monster move around randomly and not attack the player. To do this, we'll change our empty AI struct into an enum with 2 variants. Okay, so yeah, things are starting to evolve a bit and they're going to get a lot more interesting actually. So it's struct AI. Or we, no, we already made it an enum. They called it a struct, but it is an enum. I thought it was an enum already. So we have basic and we have confused. And confused has previous AI with a box AI in it. And if you haven't seen this, then you're like, what is going on here? And number of turns, I32. So if you're making like a recursive data structure like this, it has no way to know how much you're going to recurse. How many AIs are you going to put in here if you say AI? Because then the AI can be a confused AI and a confused AI and a confused AI, and it can just go on forever. So boxing it actually allows you to at least know the finite size of this at compile time, and it doesn't matter how much it recurses, because all it is that one smart pointer that you're concerned about at any given time. So yeah, let's go ahead and move this back over because there's a lot of stuff to read here. So yeah, we've made two variants now. The basic option is the AI we've used up until now. A monster moves towards a player and tries to attack. The confused one is what we want to implement now. It moves randomly for a few turns and then reverts back to the AI it had before it got confused. It's still an enum, but it uses a struct-like enum variant for confused. In Rust, enum variants aren't just empty identifiers, but can hold data too. And it's something you see me doing all the time. I did a couple of weeks ago a little macro thing, and I used enums for all of my commands, and I packed data all in them. So it's the same idea going here. So we need to change the monster creation in place objects a little. So yeah, we need to, I thought we were already kind of doing that. We'll double check and see, but I thought we already had that set up. What's going on, Puerto Nabo? How are you doing? So orc.ai. Yeah, we already have that going. I think they initially had it as a struct and then they modified it later. So we're good on that front, but we do need to change how AI take turn and everything works. So AI take turn is going to be AI basic. So basically we could just pull this out of here and say AI basic. Monster ID, usize, tcod, and tcod, game and mute game, objects, and mute object. And then should be pretty much the same thing here, except we're actually returning AI. So we'll see how that plays in here in a moment. Returns an AI basic. So let me compare the code and I'll walk through what's happening as well. So we get the position of the monster first, and then if it's in the FOV and the distance to the player is greater than or equal to 2, move it towards the player. And that's basically all that's happening there. Otherwise, if it's like 1 square away, then it can attack. So, and it has more than 0 health. So that's the thing that's going on with this closure here. We're checking if it has health. Yeah. And we know that it's closer as well. We know that it's 1 square away because that's the else clause to this position check here. So we've actually built in like 2 different checks into this. There's that implicit check there. And then basically this is where we do the mute to, which is what I broke down at the start of stream. We have 2 mutable things from the same vector here, from the same slice. So we have that function there that we wrote last time, and I kind of broke it down some more today. And then we do the attack. So nothing in there has changed. That is a complete just copy paste into that function. But now the way AI takes turns has to change a little bit. So we're going to use the AI variants here. We're just going to pull in the entire AI namespace for that enum. And we're going to get the AI component from the monster ID. Now, take is interesting. I've seen that used before, but it takes the value out of the... Oh, because we're reassigning the AI, it seems. I believe that's... Yeah, we're actually reassigning the AI every turn because it can change with the confusion state. I don't know if I would opt to do it every turn or only when it needs to be replaced, but I see what's happening. So instead of like doing a borrow or something, we're actually getting rid of the value. And so now the monster has no AI, and that's why we return the AI here from where they do their basic move. So, so we grab the AI out of there, and we say let new AI equal match AI. Basic. So we need both match arms. So I'll have it auto-complete that for me because I'm lazy. All good programmers are lazy, yes? So AI basic, monster ID, tcod, game, and objects. That's easy enough. And if it's confused, we have previous AI num turns. And here we're going to say AI confused, monster ID, tcod, game, objects, previous AI num turns. Simple enough. We don't have that function yet, but simple enough. And then we simply replace the, well, not replace, I guess. We fill in the AI with the new one. Because we already removed it, so at this point we're not really replacing it, I guess. Semantics, right? So now we'll need to make the AI confused here in a moment, but we'll step back over here and take a look at this in order to kind of fill in the gaps a little bit. So the function now does a dispatch similar to the one in use item. Based on AI type, it calls AI basic or AI confused. The AI basic function now contains what was previously an AI take turn, except that it now also returns an AI value. This is because the AI can't be copied, and that's because the confused variant uses a box AI, and boxes cannot be copied. So there's actually some reasoning there that does help a little bit to explain why they went with that take. So that's interesting. In the case of the basic AI, we don't really care since we're not modifying any data. But in case of confused, we'll want to decrease the number of remaining turns, and when they run out, swap the previous AI. A simple way to do that without running into any ownership issues is to take the present AI value by calling AI.take. It moves it out, leaving none in its place. Calling the appropriate function with all its contents, previous AI and num turns for confused, and then put whatever the function returned back as the monster's AI component. It's a bit complex if you haven't internalized option and box types and how ownership works, but it's actually quite straightforward once you do internalize that. You can try to write the AI take turn yourself without moving anything. Just use objects monster AI is mute to get a mutable reference and think through the compile errors Rust will give you. So after that mouthful, the rather anticlimactic implementation of AI confused. So I want to just take this moment to once again say, this goes back to what I was talking about at the beginning of the stream. When you're doing a tutorial like this, it's very easy to just say, here's the code, and just write the code out. Better not be, at least write the code out. Definitely don't copy paste it. But it's very easy to just like hammer that code out and not really internalize what's happening or the motivation of why something was there, why something was done the way it was done. So of course, in a tutorial, typically you are going to be kind of in that autopilot mode where you just follow along, but try to be thinking about things like that, right? Because that's what really makes you learn more. You know what I'm going to do? I'm going to be a little lazy. I'm going to copy this whole signature here. And then we'll just add in the two new parameters. Were they before or after object? Yeah. So previous AI is a box AI, and turns is an I32. And we just return an AI. So if num turns is greater or equal to 0, Still confused. I'm not sure I buy the greater than or the equal part. I would think if num turns is 0, then you're done, but we'll accept it. Okay. We'll let it go. It's not my tutorial. So we'll just move in a random direction. Move by monster ID. Okay, we're doing a rand thread RNG dot gen range. We're gonna do this twice. So I'm gonna be a little bit lazy here and just copy this while I can. And low is going to be -1 to 2. Now, I know what these numbers mean, but the question is, do you? Why -1? Why 2? I'll explain once I get done with this next, with like this semicolon. No, we'll do this next line, then I'll explain. It's a chance to think about what's happening there. Previous AI. We can actually do that. Okay. And the if may be missing an else clause, so it's mad at me. You know what, so we'll do this, and then I will explain the reasoning behind that, that range. I'll break down everything that's happening here. I just wanted to stop being mad at me. Because it's really unpleasant to look at a bunch of red like that as you're trying to explain something. Game.messages.add. And we're gonna format, because probably gonna use the monster name. The blank is no longer confused. And then objects, monster ID, dot name. And then it is a red message. And then we'll return that previous AI rather than making a new. Okay. All right, so it looks a lot better. And let me click over here real quick. So that is a good question. How the values correlate to position. Yes. So it is essentially classic, typical kind of roguelike of a tiled grid. So you move, you know, 1 over, 1 up. I think the monsters can do diagonal movement. They certainly can do diagonal movement with this implementation that we just did here. Yeah, so the reasoning behind these numbers here is because you can go 1 square. By saying -1 all the way to 2, you have to remember that the high range here is actually excluded. So you can see the way they do the brackets here. They do the square bracket on low, which means included, and they do the parenthesis on the high value, so that means it's not included. So what that gives us is a value -1, 0, or 1. So basically we're getting an X value and a Y value that says move negative, positive, or don't move at all. So that's why those numbers are picked. But again, when you're just hammering out code in a tutorial, it's easy to miss things. It's easy to not make those kind of correlations or anything. But simple enough. But I just want to try to call attention to things as I see them. That might be confusing, especially if it's somebody that's like never done this before. So actually, as for the rest of the function, let's take a full look at it real quick before I go on. So basically, I would like to see their justification for the equal here, because I don't know, I usually think if num turns is 0 that you're done. But again, it's really just a 1 turn difference, so whatever, that's how they have it set up. So maybe they'll justify that there, but basically if they're still confused, we just have a move in a random direction and we give back a confused AI with 1 fewer turn. Otherwise, we print out a message that says, yo, it's no longer confused, and we get back that previous AI, which would, in our case, just be like a basic AI. So then that basic AI gets assigned back to the monster, and it's no longer using this confused one. And that's the thing that was actually boxed up. And the movement, no, positive and negative is it's just a tile based thing. So like, if you're moving right, it's positive in the X direction. You know, if you're moving left, it's negative in the X direction. So that's all it is. Just purely tile, like, coordinate based. So yeah, here we are. So this takes pretty much the same parameters as AI basic, but it moves the monster at random if it's still confused, and it returns the previous AI otherwise. If you look at the return values in the confused case, we're reconstructing the AI confused value again with the same previous AI and a num turns decreased by 1. This is where we move previous AI instead of mutating anything. And in the else case, we just return previous AI on its own, getting rid of the confused value entirely. We have to prepend it with an asterisk to return the boxed value, AI. If we didn't put an asterisk there, we'd return the box AI, which is not what AI take turn expects. Now, the actual scroll that causes this AI, for it to appear in the dungeon, it must be added to place objects. Notice that the chance of getting a lightning bolt scroll must also change. Well, true, I guess, but I mean, we could also change the chance of the health potion. We don't have to change the lightning bolt, but sure, I'll take your word for it. I mean, it's really up to you as a designer what changes and what doesn't change, right? So let's find the scroll here. So I guess we're leaving this here. Yeah, so we're leaving this here, and we're going to add an if clause here. Else if dice is less than 0.7 plus 0.1. And so we'll call this 10% now, because there's a 10% difference between the two. Let's see, and then we'll have an else clause. And I'm going to copy all of this because I'm lazy, and because it's not really going to change much. So all we're really going to do is say scroll of confusion. Confusion bolt. It is also light yellow. It looks the same, but item is going to have to be confused type. So we're going to get some complaints. So we're going to go ahead and just generate a variant for that confused. And then we're going to get some further complaints because we actually have no function handling that yet. But that should be everything just to get that in place. We're ready to generate it in the dungeon already, but we're not ready to use it. Let's take a look at what else they have here real quick. So we're making all scrolls look the same here, but in your game, that's up to you. Cast confuse function can now be defined. Hits the closest monster for now, like lightning bolt, and later will allow targeting. And the percentages in the comments aren't quite correct right now, but they will be once we've added all the... I was going to call that out, but yeah. Because I was like, if we're doing 70 and 10 and 10, that's 90, but I thought there was a reason for it. Okay, so we'll go ahead and do this cast confuse, which is probably going to be very, very similar. So I might see about just copying a big block of that function, and we'll roll with it. But first, let's go ahead and add the confuse variant here. Cast confuse. And now we don't have a cast confuse function. So let's go ahead and just grab this for a quick and simple start, because we know we're going to need the same parameters. And here we go. So we're going to take this description and say the eyes of the blank look vacant as he starts to stumble around. And we don't need this damage anymore. And the color of that's going to be light green, because so saith the tutorial gods. Okay, and we'll use up the scroll. Monster doesn't take damage, though. So I'll have to modify that a little bit. But the other one, no enemies close enough to strike, is exactly the same. So then we look for, okay, so it's going to be a little bit different up here at the top. We're going to say find closest enemy in range and confuse it. I'll just copy this or change this over for sake of parity. And monster ID is now called target monster. And it comes from confuse range, objects, and tcod. I don't know why they changed the ordering here. That's actually kind of disturbing to me. I'm not a fan of that. But I'll bite. I'll bite. I'll play along. And if let some monster ID, now we do the AI stuff. So the first thing we want to do is replace the old monster's AI with the confused one. After some turns, it will restore the old AI. So we have to get that old one out and basically assign it as the previous AI of the confused variant of the AI enum. And that sounds a little odd saying it out loud like that, but that's what we're going to do. So the monster AI is now equal to some AI, because it is an option. It's going to be the confused variant. And previous AI, we're going to box up the old one. So we're going to say box new old AI. And I forgot to grab that because that's at the top. I was like, wait a minute, where is that? Yeah, we're probably going to do a take. Yeah, we're doing a take on it. So we'll go to that in just a second. Confuse num turns. And that should be it, except for getting the old AI. So let old AI equal, and what's it going to be? Objects, monster, ID, AI. Why are you mad? Hold on. Oh, is it? I think it's mad just because there's stuff that's not compiling. As I don't think I'm making a typo. I'm just bothered that it's not auto-completing the .ai. We're going to do an unwrap or AI basic. So an unwrap or basically says, yo, if try to unwrap it, and then if you fail, here's your default. So it just defaults to an AI basic. But we don't have two things. We don't have, well, three things. We don't have confuse range, confuse num turns, or target monster. So the quick and easy thing I'm going to do is actually get the confused stuff up here in the constants. Where's the lightning ones? Easy enough to get those up there. Stop it complaining about that. But we also need target monster. Before I jump to that, let's jump back over here and catch up with their descriptions of what's going on. But really, just to break down what happened, it's basically the same as a lightning bolt. Again, we try to find the target. Well, we do find the target if we can, I guess. And if there is nothing in range, cancel. Nothing really special about that. If there is something in range, we yank out the old ID and we replace their ID with a confused, or I'm saying ID, excuse me. We yank out the old AI and then we replace, or rather we set their AI to a confused AI that has that old AI boxed up in there. So actually works fairly well. Nice, simple way to do that. It could be a lot more complex if you wanted it to, but it's a nice, simple, quick and easy way to do it. Quick and dirty, I like it. So it says, we'll find the closest enemy again, extract its existing AI, and replace it with the confused one. Target monster should always return a monster that has the AI component, but the object.ai still contains option rather than bare AI. Not every object has an AI, even though we expect each monster to have one. We could use unwrap or expect to get the inner value, but this would crash the program. Expect would print a custom message. Here we use unwrap or instead, which will return the basic AI in case there is none. So you may choose to panic with unwrap or expect instead, to find a bug early and hunt it down, or log the error and keep going, or even allow monsters without AI and just handle that case properly. So we've also introduced the two new constants. I went ahead and just plopped those up there. So the confuse range is 8, so 8 tiles. and it lasts for 10 turns. That's respectable, I guess. And then to tie it all together, we need to add a new item type, which is the confuse item, which I already kind of did because the program was complaining. The linter rust analyzer was mad, so we had to go ahead and just take care of that. And we associate it with cast confuse in the use item function. Now, what I'm a little confused by is target monster. Are we writing that down here? What's going on? Yeah, we are writing that down here. So we're not really going to be able to test it. I don't like how they made that such a gap between the two. I think the idea was originally, it was probably written with, what was the last function? Closest enemy? Closest monster. It was probably written with closest monster in mind. And then it got replaced with the target one, but there's a little bit of a mismatch in the way, because that's a big gap. I'm going to go ahead and just keep pressing on, but what might be worth doing if you were doing this on your own would be to swap out, even though it has target monster up here being used, swap that out for closest monster and just give it a try. But for the sake of brevity, and the fact that I'm going to be doing this for a few more hours minimum tonight to wrap this up, let's just keep pressing on. But no, it's probably worth doing that if you were doing this on your own, actually swapping out for the other function. So anyway, targeting the fireball. Given that we know how to make direct damage spells like Lightning Bolt, others like Blizzard or Fireball are just a matter of finding all monsters in an area and damaging them. You should have no trouble creating them. But it would be much more interesting if the player could choose the target properly, and that's a feature that will benefit many spells. In addition, you can use the same system for ranged weapons like crossbows or slings. So let's do that. We're going to build a mouse interface. It's also possible to make a classic keyboard interface, but it would be less intrusive and a bit harder to code. If you prefer that, consider it a small challenge. Or I said intrusive, intuitive. Less intuitive is questionable. I mean, if you play a lot of roguelikes, there's a reason they said classic keyboard interface. We already have some code for getting the coordinates of the mouse, and checking for left clicks is trivial. When it happens, mouse.L button pressed is true, so we just need a loop until the player clicks somewhere. By redrawing the screen with every loop, the names of objects under the mouse are automatically shown, and we erase the inventory from which the player chose the scroll, otherwise it would still be visible. Okay, so this is a target tile function we're going to be putting together here. Let's take a look at it. Let's get this thing set up. We'll do it right before main. Typically, I've been putting functions just before main because this tutorial is, and it's known by the tutorial. It's not me, complaining. It's actually mentioned in the tutorial that putting it all in one file is not really great for organization, but they do it anyway because that's kind of how the Python one is set up. So like this is what we have, right? From skimming over the next one I'm going to be doing, that one actually has like a proper like mod system. Everything's in modules, and it looks like it's very well organized. But that tutorial is way more in depth, way more advanced. So that's next. We're going to do the simpler one first. And you know what? I'm so lazy that I'm going to actually copy these because I'm tired of typing the comments like that. Return the position of a tile left-clicked in the player's FOV, optionally in a range, or none if right-clicked. So it's called target tile, and it takes tcod and mute tcod, and it takes game and mute game objects, and object max range option F32. Okay. And it returns, this is like your targeting tile. Okay. We're going to use tcod input key code escape. So I guess escape is going to be how we cancel it. So what are we taking in? We're taking in the tcod, we're taking in the game, we're taking in all the objects in the game, and we're taking in a max range, which is optional. So I guess you can decide that you don't want a max range on something. And then we optionally return two coordinate, or a coordinate. So that's to suggest that if you cancel, you're not returning something. So we're going to do an infinite loop here. And we're going to render the screen. This erases the inventory and shows the names of objects under the mouse. So we're going to do tcod.root.flush. Let event equal input check for event. Input key press. Or input mouse dot map. Now, last time I dealt with the mouse stuff, had some issues. Hopefully that doesn't crop up again today, because that was a problem Monday. We'll see what happens. And then I am asking a question right now of what e.1 is. What it probably tells me is that it's a tuple struct. The event thing is a tuple struct. Actually, no, it's right there. Event flags and event. So we got the event. Yeah. And of course, if I were paying more attention, I already know because we named it event. But I was fixated on how that variable works. So we're getting the second thing out of it because indexes start at 1. Or they don't. That's the joke. Tuska earlier joking about arrays starting at 1. Indexes don't start at 1 is what I meant to say. They start at 0. Let's see. So event mouse m. Yeah, so we're going to match on the event. If it's a mouse event, tcod.mouse equal m. If it's a key k, we're just naming it k. tcod.key equal k. None. tcod.key equal default. This is, I believe, the same code we used previously. It's very, very similar. I recognize it. Even though it's been a couple days, we're going to do a render all with tcod game objects and false. Huh. I just got 1,600 Primo gems. Okay. I just saw an email pop up, and it's like, "Dear traveler, thank you. Here are 1,600. Okay, so we set the mouse thing, we set the key thing, and if it is a none, we kind of reset the keys so we don't register like false key presses. I forget the exact reasoning behind that, but we could go back to last time to confirm that if we want. We render everything, and then yeah. We get this x and y value, tcod.mouse.cx, so the x coordinate and the y coordinate, both as I32. And then we have this right here, so there's going to be more stuff going on. So it says, yeah, we have to flush the console to present the changes to the player. Now we returned the clicked position if it's in range and visible. Okay, so say accept the target if the player clicked in FOV, and in case a range is specified if it's in that range. All right, so let in FOV. Oops. Equal x less than map width and y less than map height. tcod.fov.is in FOV xy. Let in range equal max range dot map. Or, so map or is not one I use that often. Let's confirm how it works. I think it's like you do, I don't know. We'll see. And it should be distance 2. Their code says distance, but it should be distance 2. Pretty sure. Also, I mistyped that. No method called distance. We'll take a look at that in a moment, because I don't know if they're... yeah, they're creating distance. Okay. Then that's better. Because I was like, that takes an object. Okay, so we're good. If tcod.mouse.l button pressed, I remember mentioning that, and in FOV, and in range, return some XY. So there's a lot going on here. Let's break down some of what's happening. We're not entirely done because we have to, like, you know, make this happy, but let's break down what's happening here. So we want to target a tile. So the first thing we do, we start this loop and we render the screen to erase the inventory and show the names of objects under the mouse. So we do that every frame, basically. And we check for an event. And then we're getting these coordinates, basically. So what this allows us to do is basically every frame, if there is a mouse event, or every time a mouse event shows up here, when we do check for event, that's going to set that event into tcod.mouse. And then so that's accessible here with the CX and CY, tcod.mouse.cx and CY. So that's how we get our X and Y coordinates out of tcod.mouse. And then we do a couple checks. We ask, is it in the FOV? So we check to make sure that X is within the map width and height. Or, well, X and Y are within the width and height. And then we check, is it actually in the FOV? I'm a little curious if it would not be possible to just feed that to check if it's in FOV and ignore these, because something that's not even within the map width or height would not satisfy that anyway, I don't believe, but just food for thought. And then, so that's whether it's in FOV or not. Then we ask if it's in range. We do the map OR. And the map OR does have us a default value. So let's see how it works. Return the provided default result if none, or applies a function to the contained value if any. So that's what it is. So because in range is option, if it's a none, we get true, and it just says, yeah, you're in range, right? Otherwise, if we did specify a range, we actually compute the distance to the target and figure out if it's within range. And if the mouse button is pressed, we return those X and Y values. Now, I'm a little bit curious about that, however, and I think we're going to hopefully... I'm seeing something that feels like a bug to me, so let me actually explain it, because I haven't really gone ahead yet. What if it's not? Oh no, oh my bad. I called it out earlier as I was writing it. No, I missed it. It's right here. If the button's pressed and it's in FOV and it's in range. Okay, yeah, we're good. I was like, wait a minute. What if it's not? Okay, so we're good there. So let's actually look here at the tutorial, take a quick look at it, and get back up to speed here. So we've just done this. We flushed the console to present the changes to the player. We return the click position if it's in range and visible. The isInFOV method expects that X and Y are within the map's bounds, so we need to check for that. If the max range is none, we allow any range, so we make maxRange.mapOr return true. Otherwise, we need to check that the range from the click position to the player is lower or equal. We also make sure that the target is within FOV to prevent firing through walls. Finally, we need a way to cancel the targeting UI. Okay. So then we haven't done that yet, but that's the escape that we already pulled into scope. So let's go ahead and do that. So it's going to be after all this, if tcod.mouse.r button pressed, or tcod.key.code double equal escape. Return none. Cancel if the player right-clicked or pressed escape. So this returns none if the player pressed escape or clicked the right mouse button. If they didn't do any of that, the loop continues. Next, we add a method to object for calculating a distance to a specific coordinate. We already have one for distance between two objects. It's going to be the same basic thing. It's going to be the Pythagorean theorem. And that's all for targeting a tile. We can then create a simple fireball spell. So we're going to get onto all that. It's a big cast fireball, but we're going to get onto all that and do it. It's not going to be too bad, I promise. So impl object. And where's the other distance? I'm going to put these next to each other. Pub fin distance and self. And it's going to be x I32 y I32. And it returns f32. We say x minus self dot x. Pow 2 plus y minus self dot y plus pow 2 as f32 dot squirt. And we'll say return the distance to some coordinates. Beautiful. Okay, so where is cast all these other things? We're gonna need to cast fireball. Let's do cast confuse. We're gonna rename this to cast fireball. Okay, it should be happy now. I don't know how much I'm going to be able to reuse from this, so let's just actually kill it. But we get to start with something, so it's better than nothing. So we ask the player to give us a target. Left click a target for the fireball, or right click to cancel. Light cyan or cayenne. And then we're going to actually call that function that we just did. So it's going to be target tile, tcod game objects none, some tile position, tile position none, use result canceled. Yeah, so we're getting that tuple back from the target tile, which we just wrote. Okay. And then what do we want to do? Game.messages.add format. The fireball explodes, burning everything within blank tiles. Fireball radius orange, because it's fire, get it? We don't have a radius yet. We'll define it in a moment. For obj in objects, not sure why we called it that. If obj.distances dot distance xy is less than or equal fireball radius as f32 and object.fighter.isSum game.messages.add format. So only things that have a fighter component can actually get hit by this, just like most other things so far in the game. But I actually really like the idea of, you know, maybe an actual fire system or something where, you know, this would be burning things, right? I think that could be cool to see. What if you could burn scrolls? What if things had materials or something and it was based on the material as well to determine like whether or not it gets burned? Okay, so we're missing a couple constants, so let me go add those. Const lightning. Boom, we can add those right there. So there is a concern, and I wonder if the tutorial is going to call it out, but there is a concern I have here, and this would be something that I would hope, you know, you as a viewer or you as someone participating in this would recognize or be asking questions about. But if not, it's okay. But we are essentially checking every single object in the game. And in our case, that's not going to be a big deal. But, you know, we're looking at every single object and we're computing the distance. We're doing all this. It's not going to be a big deal. We're not dealing with the large enough game for it to matter. We're only going to be dealing with, you know, probably less than 50 objects at any given time. And modern computers and stuff, they're so fast it's never going to matter, right? But the point is, think about what that would mean in a larger game where, you know, you're dealing with scaling issues and whatnot, where you might be dealing with a lot of objects. If there's some way you can do what you might call calling and automatically rule out some objects from your computation, that's actually a great strategy to make things run a lot faster. It's also much more complex. But what you could do is, imagine if you had a world with chunks and you cast a fireball in a chunk in one location. Well, we know a chunk way over here is not going to be affected by something that happened over here. You know, maybe you know only things within a one chunk radius matter for a certain calculation. So you can really call what you're actually using to calculate. That's just one example of how you might be able to do something that's a little bit more fine-tuned than simply every object in the game. But it's fine for this game. So this is actually a perfect example of how some people actually are too, I don't know if obsessed is the right word, but optimization is good, but sometimes it's not needed. Sometimes good enough is good enough. And there's a reason that you could write this game in Python because it's really simple. We're not making a AAA game. We're not making Fortnite. We're not making Metal Gear Solid 5 or something where it matters what language you implement the game in, and it matters that everything is optimized. That's not going to matter for a little game like this, right? So good enough is good enough, but it's something to think about that in a larger game, you will run into issues with code like this where you're having to check this for every single object in the game. Imagine you're doing something even as simple as Conway's Game of Life kind of thing where the game grows basically exponentially because you think of it as like a tiled grid, and then you say, well, you know, a 10 by 10 is 100 squares, right? 100 tiles, but you know, what is 12 by 12? 144. A 4 by 4 is only 16. Like, you know, it's just squared values, right? 13 by 13, what's that, like 169 or something? Like, it grows rather rapidly how many tiles you have. So if you go up to even like 100 times 100, it's like, whoa, we got a lot of tiles we got to process now. And if we're having to do that for every tile in the game, like checking it against these other things, like it can be a lot more computationally expensive than you would expect. It grows very quickly on stuff like that. So anyway, we've got the constants. We've built this code out here where we basically we get the target, and assuming there is a target, we go ahead and actually basically check everything in the game to say, well, does it get hit, right? Are you within the fireball radius of that target? And if so, then you got hit and you need to take fireball damage. That's about all there is to it. It's pretty simple. And they call it a simple fireball spell. So this also uses the new distance method. A scroll that casts the fireball spell must be added to place objects before the confused scroll. Know why it has to be before the confused scroll, but sure, I'll take your word for it. Well, I guess they matters a little bit for the rarity. I would like to see a slightly better way of determining this is more of like a table, it's doable. You can actually with the rand crate that we're using, you can basically do a weighted distribution, and I think that gives you, you know, kind of better results ultimately. But again, it's good enough. Not going to get too nitpicky. Else if dice. So we have the lightning bolt, and then we'll do another one of these here. Else if dice less than 0.7 plus 0.1 plus 0.1. Whoops. Let's get this back here, and let's get my formatting right where I'm happy. Okay. So we'll create a fireball scroll. 10% chance. Let mute object. Actually, I'm going to be lazy like I did before, because why am I writing all this out when it's the same code? So instead of scroll of lightning bolt, scroll of fireball bolt, scroll of fireball, and everything else is the same except it's going to be called, it's a fireball now. So then we get to follow the rabbit hole of like how to fix that. We'll make a new variant, and then we already have our function in place that's going to be called. So let's go to here and we'll say fireball cast fireball. So that makes everything happy. Let's click back over here and just skim past what I just did. There's not really much going on. So yeah, we'll add that before confuse, which I just did. It is like its name, scroll of fireball. It's a fireball variant, not crazy. Change all the 15% and 0.15 to 10%. Now there's 3 scrolls now. I think we already did that. Yeah, I think we already did that above. I think there's a little bit of a typo here. They probably changed how they were doing it as they went through the tutorial. But if we look before, else if dice, yeah, see, it's not 0.15, it's 0.1. That's fine. Just want to call attention to it, why it says that and why I'm not doing that, or it might seem weird because it was already in place. So there we are. So they each have a 10% chance of appearing. If we try to compile now, Rust will complain there's no fireball. Yep, we just did that. So we add it to the item enum, and then we add that as our callback here, basically, for the match statement. And then finally, we're expected to pass a mutable map to cast Fireball because target tile requires it, but none of the other spells required it yet. Since they all must have the same function signature, we have to add it to cast Heal, cast Lightning, cast Confuse, as well as use Item. So here's what the unused bit looks like now. And this is another thing I've actually already previously called out, but we'll draw some attention to it because this is a little bit of a discrepancy in the way they're doing things. So, but we'll look at the match unused, inventory ID, tcod game, and objects. And where is that? Oh, right here. So we already have that in place, and you'd be like, why? I thought we're following this tutorial. Why did you jump ahead? I didn't. The tutorial actually had these functions already taking in the correct parameters, and in some of these cases, I mentioned that we have these underscore parameters here, and then that's a way to tell the linter basically like, hey, ignore this. Like, I know we're not using it, but don't get mad at us, don't complain. The underscore says it's unused intentionally. But why would we want to do that? Because we're treating this like a callback, right? So here, this onUse is actually a function, right? So look at our type here. It's a function with a usize, a mutable tcod, a mutable reference to a tcod, a mutable reference to game, and a mutable reference to the object slice. So all of these have to abide by that same type, right? Because when we get down here and we actually call the onUse function, we can't like have different parameters passed in, right? Depending on the type. So we do have to, abide by it's not quite a contract, but it's almost like a little mini contract here that we're defining by this variable type being a function that takes in those parameters. So we needed that in place. The tutorial already did have that set up for us, so I didn't have to do the refactoring right now. So I'm happy for that, but I'm a little annoyed that it's a little discrepancy in the tutorial. So I'm glad to call it out. Not as a way to like talk shit, but as a way to just say this is why things are happening the way they're happening, right? So anyway, let's get back to it. So we've done that. Yeah, we pass the map. Everything's good there, and now you can pick up fireball scrolls. They're quite handy to roast large groups of orcs. Try not to get burnt though. It also damages the player. I think it adds some strategic value, balancing the spell. If you do want the player to be immune, you can add enumerate to the for loop and check whether the ID is different from from the player. So I'm not going to do that, but it's really, really easy because we're already checking if it's within the fireball radius. If it has a fighter object, it's literally just ID and player, and you just put that dot enumerate there, and this like tuple notation here for the ID to unpack the ID and the object. So it's really, really simple. I'm not going to do it because I'm kind of okay with being hurt by it. It seems fun. So anyway, finally, this target monster function, because I would love to test this out, but the way it's written, we haven't done the target monster function yet, and we still need that back for is it confuse? I think it's confuse. Yeah, whatever it was, it's been, let's see who's complaining. Let me double check. Yeah, confuse is supposed to be using target monster, apparently. So, we need to write that. Targeting single monsters. Let's not stop there. Area spells like the fireball are fine, but many spells affect single monsters. Can we make a handy function to target a single monster? Sure. It'll simply wrap target tile and stop only when a monster is selected. All right, so let's do that. I'm happy to be finally making this function. So that is nice, wrapping target tile. So this returns a clicked monster inside FOV up to a range or none if right-clicked. Okay, so it's yeah, we're not actually targeting just a tile, it's going to be a monster. Okay, so then I think it's going to take all the same stuff. So if I'm right, we can do this. And we can say fn target monster, and then just pass in the same exact parameters, and then it's also going to do this option usize, because we're actually getting the index, I guess. So there's a slight difference here in that we're getting the index of the monster. Yeah, but everything else should be the same. tcod game and object, option F32, boom. Yeah, I'm happy with that. So loop match target tile, tcod game, objects, max range. So every time they click, there's going to be a check. Sum x, y. Let's see. What are we matching? Oh, right. Target tile returns a tuple, so that's what this X and Y are from. Okay. Yeah, because we're matching against the results of target tile. Return the first clicked monster, otherwise continue looping. Iter.enumerate if object.position y and object dot fighter is sum. So if the position matches, yeah, so loop through every object. If the position matches and it's a fighter and the ID is not the player, return that ID. In a none variant where we broke out of target tile, we just basically do nothing. We return none. And that'll be used up above. So this function takes 4. So we also give, okay, tcod. Let's see, what's target? What does it take? Range is the last. Confuse range is an I-32. Closest monster. You know what? We are going to switch that to closest monster for confuse. Because it's actually kind of set up for that, but also not. There's a little bit of funkiness going on. Actually, wait. No, hang on. tcod dot tcod objects and confuse range. Yeah, I'm not sure why theirs was so off on the way the confuse was set up, but I think we're good now. And then we're actually going to make some changes to confuse as well, which seems interesting timing. I didn't even notice that. So before, this is what I just did on the target monster. And then it says the confuse spell is a bit weak since monsters that move randomly can be hard to hit before the spell runs out. So we'll compensate a bit by letting the player choose any target. Okay, no, we're making that change now. Conveniently testing our new function. Just replace the first two lines of the cast confuse function with, and yeah, we'll make that swap now. That swaparoo. So where is cast confuse now? Even though I was like just there. Alrighty, so where are we at? Oh, it scrolled. No wonder I'm confused. Okay. So instead of finding an enemy, we're going to say ask the player for a target to confuzzle it. Game.massages.add left click an enemy to confuse it, or right click to cancel. Light cyan, and let monster ID, and now we're going to target monster, and it's going to be tcod. We need game as the second thing. Objects, and then the max range. Oh, whoops. Some confuse range. Oops, I got a little hype. Some confuse range as F32, right? Okay. Next up, we're almost done with this section, then we'll test everything at once. It's been a beefy one. We're actually like almost 2 hours in. Granted, I spent 20 minutes early on doing something different, but still. Dropping items. Right. There's an inventory feature that didn't make it into part 8 since it was getting too long. You'll miss it when you hit the maximum number of items in your inventory. Dropping items. A new function will do that. To drop an item, you just add it to the map's objects and remove it from the inventory. Then you must set its coordinates to the players so it appears below the player. All right, so we'll make a drop item function, and then we'll set the D key to show the inventory and let us drop. So to let the player choose an item, we'll call the inventory menu, and when the player presses D, they'll drop the chosen item, and so we'll add it to handle keys after the inventory key. Some new spells targeting dropping items. That's enough for now. So we'll see how the spells affect our strategy. They'll surely make things much more interesting, but we'll do that after I add the dropping. So let's go right before main. This has been a long one, but it's been good, I think. We'll see how it works out. Drop item, inventory ID, use size, game and mute game, objects, and mute vec, object, whoops. Now, let mute item equal game.inventory.remove. So remember, remove actually gives us, it actually takes it out of the vec and it just shifts everything over. Yeah, because it shifts everything over the remaining elements, it has a worst case performance of O of N if you remove the first thing. So that's interesting that we're going with remove. But it also, it just gives us the thing, so we don't actually, yeah, okay, good. Item dot set position objects dot, or no, objects player dot x, objects player dot y, game dot messages dot add format. I like how the messages are just a vec, because like anything that works on a vec works here. It's kind of convenient. All right. So there we are, right? Out of the inventory, into the objects. Let me check something. Game.inventory.remove. Swap remove is the one I was thinking of, where it just pulls the last thing in to replace it. And that's like, yeah, we don't maintain the order, but we're fast. That's all you wanted, right? Okay, so then we need to go back to the key stuff. So key code, this is where we need to be, and we'll do it right after the inventory. Let's, because I don't feel like typing all of that stuff, we'll just replace that with a D. And we'll show the inventory. If an item selected, drop it. And the only thing that's different, let's see, inventory index, inventory menu, game.inventory, press the item key, or excuse me, press the key next to an item to drop it, or use any other to cancel. And mute tcod root, and we'll just say drop item. Interestingly enough, takes 3, but 4 were supplied. Inventory index, game, and objects. Why don't we need... Why did we need tcod for use item? Let me confirm. On use is using it. Okay. And then on use. Actually, yeah. These things need it. Some of them do. Closest monster deals with it. Sorry, like I gotta just trail through this to confirm, because we're checking if they're in the FOV. Okay. So the reason we need, let's see, drop. Okay. So the reason we need to pass tcod into use item but not into drop item is because some of the effects of using items involve like the FOV and stuff, which is packed up into tcod. Okay, that makes sense. Got it. All right, so we got a lot of new things added. Let's take a look at it in action. I'd like to try to use everything. I don't know if that's going to be a guarantee or not. Die. Stupid troll. All right, what scroll do we have here? Fireball, sweet. I don't know what the radius on it was. What else? Lightning bolt, we've seen that in the past. Okay, let's, you know what? I don't care if I take damage, let's go for it. So go in here and we'll do A for fireball. And then I actually have to click where I want to use it, so we'll click on the orc. And it explodes, burning everything within 3 tiles, and the orc dies. Cool. Get some health potions. We'll probably go ahead and use those. Confuse would be cool. I'd like to see it in action. All right, let's heal up. Another lightning bolt. I might think about changing the values. Basically, I could go in and hard code confuse to spawn more. That's one way to do it. I'd like to see it in action. Not another fireball, no! Oh, this is way over here. Oh no! I died. Kind of rushing a little bit, obviously. Like, can't play it that strategically. I'd like to see these things in action. Confuse. Damn it. Alright, where's my healing? Boom, and B, and C, and C. Actually, I don't think I needed all those. Yeah, I didn't. It's fine, though, because the code doesn't allow us to use one that we don't need. Okay, where are we at? Come on. Get some confusion. I better not find one, like, I kill all the enemies and then find one. Alright, what do we have? Lightning bolt and a lightning bolt. Just get him out of here. Damn it. Alright, we'll do one more quick run. I mean, assuming I don't, like, die immediately. Another fireball. Come on. Like, equal chance. That's how randomness works, right? There we go. All right, we got confusion. Let's try it out. Let me heal up a little bit. The inventory stayed open. I'm not sure why I did that, but I actually kind of liked that. I think it might be some of the weird key stuff that I was told about when I had the issue the other day with it crashing, and I found that fix. Use the orc. He looks vacant as he starts to stumble around. Yeah, so see, he's not coming toward me. Now he's no longer confused because it was 10 turns. 10 turns goes quick, but remember, every single tile I move is a turn. All right. So that's that. I don't think I really need to do much more. I think we could easily win. We could kill everything this time. So we're going to go and back out. Okay. That is it for the first part. Took a little bit, didn't it? Next part is the main menu and saving. So a quick little description here is a main menu complete with a background image and the ability to save and load the game. So we'll see how this one goes. But before I do that, I'm going to take a short bathroom break and stuff, and I'll be right back, and then we'll continue on. I'm going to leave you with some music. All right, we back up in here and ready to go. So let's work on a main menu and saving. Now that our game is bursting with gameplay potential, we can think about those little things that diehard fans will surely miss during their long playing sessions. One of the most important is, of course, a save and load mechanism. This way they can go to sleep and dream about your scary monsters between play sessions. Tidy initialization. Choose between continuing a previous game or starting a new one. We need a main menu. But wait, our initialization logic and game loop are tightly bound, so they're not really prepared for these tasks. To avoid code duplication, we need to break them down into meaningful blocks or functions. We can then put them together to change between the menu and the game, start new games or load them, and even go to new dungeon levels. It's much easier than it sounds, so fear not. Take a look at your initialization and game loop code. After all the functions, I can identify 4 blocks. System initialization, initializing the tcod window and consoles. Setting up a new game, everything else except for the game loop and the FOV map creation. Creating the FOV map, and starting the game loop. We can use these as the building blocks to make up the higher level tasks like loading the game or moving to a new level. Create a new game. So here they are. Create a new game, set up the game, create FOV map, start game loop. This is what we have now. Load game is load data. We don't have to deal with this block just yet. Create an FOV map and start the game loop. And then lastly, we can do advanced level to set up a new level. We won't deal with it yet either. Create FOV map. The game loop is already running and we'll just continue. Well, let's put everything from main except for the system initialization and the main loop into a new game function. Okay, so let's go ahead and do that. See, I like that kind of function. You know why? Because I get to just go down to main and I get to say fn new game, and it takes tcod and mute tcod, and it gives us back a game and vec object. Okay, and then place the player. Let's see. Create. I'm going to say instead of that, we're going to say create. We're going to change it to match theirs. So create object representing the player. We're going to get the player. We're going to set him alive. We're going to give him a fighter. We're going to get objects and put the player in it. We're going to do the game. And we did it initialize FOV, which I haven't done yet. Okay, so we'll copy that FOV stuff. And then we did the game message thing. So basically all of that goes into new game. The game message thing goes in there as well, because that actually does make sense for starting a new game. You give that message. And this is in an initialize FOV function. So if I do this right, if I do, let's actually put this in here as well. We'll try a refactor into function. And instead of fun name, we'll say initialize FOV. They spelled it differently because they're using the British English spelling. But same thing, close enough. All right, so that should be that. There's a reason we abstracted that out, by the way, because what we're going to end up doing is if we're making multiple levels, then we're going to be doing the FOV for like each one, right? For each level, it's going to have its own FOV. We're going to have to keep initializing it every time. So anyway, we return a tuple with 2 elements, the vec of objects and the game struct. New game is calling initialize FOV, so we need to create it and move the FOV related code to. Oh, I just did that. Okay. Well, that's fine. And if we take a look at my code, it should be exactly the same. For Y in the map height, X in the map width, set FOV, block size, yeah, it's the same thing. So it's good. Literally just copy paste that out of there. See, this one's going to go fast, isn't it? Well, we'll see. Finally, the game loop and the few bits before it belong to their own function as well. All right, so let's take a look at that and get that going. I feel like I can make this one size larger, but it gets really, really bad. It's so bad. All right. What is this function called? Play game. Effin play game. Tcod and tcod. Game and mute game. Objects. I always do that on objects for some reason. And I do a semicolon instead of a colon as I'm typing. I have weird typos that I make. Like when I'm trying to type new, I do N32, or I sometimes do IEW instead of I32. So I have weird typos that my fingers just naturally gravitate toward for some reason. So here we want to get the FOV recompute and basically the entirety of the while loop here. So let's just yoink that out of there. What I really should have done is actually extract into a function, but it's fine. Because we could probably just say play game and tcod and mute tcod and mute game and mute objects. Why not? Oh, I know why. Because I haven't... Well, they're probably going to call them here in a moment. Yeah, they're actually going to call them here in a moment, so let's take a look at it. But basically what we just did is we took previous player position, which we're using for the FOV stuff, and then we took the entirety of the while loop. So we clear the screen, we do all the fun input stuff with the mouse and keyboard there, and then we actually do the rendering the screen. We flush, we do actual handle keys and exit the game if needed, and then we do all the AI stuff basically. So that's about it. Just moving it into a function instead of having it in main. So then main, we do new game and play game from the slim down main function. So this is all that's in main. Very short now, very sweet, makes it a lot easier to work with. So let's take a look at main. We have root already, and we have tcod. So I'm not sure where the set FPS happened. Was that somewhere in here already and I missed it? You could probably... Where would that be? Set FPS. Oh, it's in main. It's at the top of main. Okay, they did it before. So we'll just slide that up here. I like how I still have my logger even though I'm not using it. So then we simply say let mute game, mute objects equal new game, and mute tcod. A lot cleaner now, at least main is, and that's gonna serve well for this refactor that we're doing here to allow the game to have like these menus and stuff that we're talking about, like the main menu and saving and all that. Now something is still mad, I think. What's mad? Why are you mad? Oh, it would help if I return from the function, right? So we just want to say game and objects, right? Thought so. Where's objects? It's a vec of object. Yeah, that's right. So why is this mad down here? Cannot assign, which is behind that label. Okay, this needs to be mute. Oh, is this one that I... No? Not sure. Cannot... Okay, this is going to be... If I'm not mistaken... This is a weird case where we have to have this mute keyword here an extra time. And I always question when I see that. Let's take another look here at their play game function signature, just to be clear. They are not doing it. You know what I think it is? It's because I was passing. Okay, okay, hang on. Let's take another look. That makes it happy, but I don't like that. It's very redundant. It's not clean. So instead, they're already mutable references. I was like double mutable reference, basically. So this is all we need. We can get rid of those now. And it's a lot happier. I'm surprised. Do we even need that? Yeah, we don't need the reference on that. That should still be able to run. Yeah, everything works. Inventory works. Boom. Yeah, we're good. See? Perfect. All right. Little distraction there, but we are good to go. So where was I at? Right down here. So we call new game and play game from the slim down main function, and boom, we are good to go. We are happy. We do the set FPS, we do root, we do tcod. Tcod has root in it. And then we make the new game and get the game and objects out of it, and then we feed them in here, and we are good. So let A be equal some tuples, how we turn a tuple into its parts. We've actually kind of been doing that already. And like match statements or for loop, or for loops with like iterators, iter and enumerate. We do that same kind of syntax. But anyway, we have to put mute in front of each one, so Rust lets us change them later. You could think of let mute A, mute B as two separate bindings, let mute A equal and let mute B equal, except since new game returns a tuple, we can't really have them as separate. Anyway, the game should compile again and the setup is more modular, which will come in handy in the coming sections. So first, the main menu. To keep our main menu from appearing a bit bland, it would be pretty cool to show a neat background image below it. Fortunately, tcod lets us load and display images. Since libtcod emulates a console, we can't directly show arbitrary images since we can't access the console's pixels. We can, however, modify the background color of every console cell to match the color of a pixel from the image. The downside is that the image will be in a very low resolution. However, libtcod can do a neat trick. By using specialized characters and modifying both foreground and background colors, we can double the resolution. This is called subcell resolution, and this page of the doc shows some images of the effect at the end of the page. Well, let's take a look at it. Never mind, it can't be found. Okay. This means that for our 80 by 50 cells console, we need a 160 by 100 pixels image. We'll be using the image from the original Python tutorial. Alrighty. We will download that. Give me just a moment. Save it as in the tutorial. We'll just call it menu background.png. Right. So main menu. Now we're actually, okay, we're making a function called main menu, and we'll break down the parts. We're going to load the background image, exit if the loading failed, show the main menu in a loop, either start a new game or quit, and if the player selects anything else, keep showing the menu. Okay. So let's write main menu. And you know what we're going to do? We're going to do it right after tcod because I see what's going to happen already, and this is where it's fun. This is where it gets cool. So fn main menu, tcod, and mute tcod. We don't have any game or anything, no objects or anything in here, right? So let image equal tcod, image from file. I see you sneaking in there, Mr. Semicolon. Get out of there. Get out of there. Wait, what was this? FN from file. Oh, okay. Yeah, I was like, oh, it tried to autocomplete to something funky. Menu background dot png. Cool. And then actually we're gonna say a dot OK dot expect background image not found. Easy enough, so we'll get the image. If we fail, then we just crash, we're done. While not, tcod.root.window closed. Now this, okay, now I see what we're doing. Okay, I was like, can I copy this from anywhere else in my code? No, but we're gonna show the background image at twice the regular console resolution. tcod image blit 2x and image 0 0 -1 -1 mute tcod dot root 0 0 show options and wait for the player's choice. Let choices equal ampersand play a new game, continue last game, or quit. So we're building out a an array of strings which represent the choices, and then we actually have this menu here. Choices 24 and mute tcod.root. So we have this menu function that we wrote a long time ago, right? And we can use it again with these three choices to actually make the player pick what they want to do. That's a nice use of what we've already written. Match choice, sum 0. That is, yeah, okay, yeah, I see. I know why it's 0. Okay, so 0 because it's the first choice. So index 0 is play a new game, index 1 is continue, and index 2 is quit. New game, let mute game, mute objects, mute game. That's a bit of a an artifact of how we did that by indexing into like the inventory and stuff when we do the choices, right? For the for when we use that menu for other things, we index into the inventory basically. So it's a little bit of an artifact of that, and we just have to know what our choices represent here, which is admittedly not the best, but it's not terrible. So we're gonna have the other option of 2, and 2 is going, or excuse me, of 1, and 1 is going to be continue a game, but we have to be able to save before we can continue, so we're all good there. Now replace the calls to new game and play game in main with main menu. So basically we spool up what's absolutely necessary, and then our main menu is just like a loop that brings us into different stages of how the game is going to flow. So let's take a look and follow this for a moment. I've already kind of broken down what's happening here. So then we do this, we replace the calls to new game and play game in main. And if you try it out now, you'll see a nice menu with a dungeony backdrop. Now let's add the game's title and some credits. We'll do that in a moment. We're going to try it out first. Assuming it's going to find the image in the right place. Yeah, look at that. That's looking cool now. And I can play a game. I can do this, and then I'll die, and nothing will happen because we're not actually handling it yet. But when I hit escape, we go back to the menu. Well, I mean, we kind of are handling it, but we're not like force kicking back is what I'm trying to say. B does nothing. C actually does quit. Pretty good stuff. It's way cooler now, isn't it? So let's add the game's title and some credits. You'll probably want to modify the values. So we'll put this in the main menu before calling the menu function. Alrighty. Where are we at here? Before menu. It doesn't really, we can put it up here. tcod root set default foreground light yellow tcod.root.print ex. That's the one that prints okay, yeah. Not the one that does the rectangle. Screen width over 2. So we're going to put it in the midpoint. Screen height over 2 minus 4. So we're going to put it near the midpoint. Not quite though. Background flag none. Text alignment center and tombs of the ancient kings. I had toms before. I typoed it once. Root.print x, and it's going to be screen width over 2. Over 2. Screen height minus 2. This is going to be at the like the very bottom-ish, or yeah, I think. Yeah. It's going to be just above the bottom. Background flag none. Alignment center once again, and by put my name there. Oh my god. And there we are. Tombs of the Ancient Kings by Shaka the Gnome. Cool. Right? Oh, I can't use escape to quit, but that's okay because I can use C. All right. So let me click back over. Give me 1 second though. Sorry. Sorry about that. Okay. So we just put all those in. We put the credits and stuff. It says you'll notice that the menu rectangle starts with a blank line. That's because the header string is empty, but root.getRectHeight reports its height as 1 by default. To make the line go away, we need to check that the condition in the menu. We need to check that in the menu function. Okay. I'm not sure that I noticed that. So I want to run it again. Yeah, I'm not 100% sure that I'm noticing this. The menu rectangle starts with a blank line. Oh, I think I do see. It's really hard to see though. It's really hard to see over because it's such a dark background. But I guess, yeah, there's a blank line there because we gave it, okay, I understand. Yeah, we gave it no header. Right, okay. So what do I do to fix it now? We'll check the condition in the menu function. So menu. And calculate total height for the header after auto wrap and 1 line per option. So we'll say let header height equal, it's going to be a little bit different. So let header height equal if header.is empty 0 else, and I think root.getHeight, yeah, it's going to default to the other stuff that we had. Just like that. Let height, options.lens at 32 plus header height. Okay, all that's the same. Except no semicolon. We need it here. There we are. Okay, and then finally when you start a game, go back to the main menu with escape and start another game results in a bug. Parts of the first game are still... Oh, we never tried that. Okay. Let's try it. Let's see what kind of weird bug I can encounter by doing that. So we'll go cargo run. And we'll play a new game. We'll just do this for a moment. We'll almost die. We're getting that confusion now. So we'll hit escape, and we'll say play a new game. Well, in this case, I didn't get that. Unless, like, if I come over here... Yeah, I'm not seeing that myself, but I don't know how much we have to play to encounter it. Yeah, I'm not getting the bug that they're referencing, but I'm not gonna say it's not a bug. I'm just not seeing it. So we'll add a little thing here to fix that. Basically, at the end of initialize FOV, what do? They just unexplored areas start black, which is the default background color. tcod.con.clear. There it is, a neat main menu with only a handful of lines of code. Yeah, it actually didn't take very many. So I like that. It's fun. Okay. Now for saving and loading. I'm also questioning something, because this has been 2.5 hours. I said I was going to like complete it at all costs, but man, this is going to take a minute. 11, 12, and 13. Let me see how long they are. Pretty lengthy. Yeah, that's pretty lengthy. You know what I'm thinking is I might actually not make this the final. I'm thinking of maybe saving the rest of this for Monday. Or even doing another coding stream, sneaking it in somewhere, because that's quite a bit. Even though it's already a little over 2.5 hours, and we're not even finished with the second of 5, and those other ones look long. This one's going fairly quickly, but I think we're going to be in for quite a bit. I might try and do dungeon levels, and I'm not sure. We'll see. We'll figure it out. I might actually make this a shorter one, and we'll do another shorter one. I think it's a little bit better than trying to cram too many things in at one time. It gives me a chance to relax a little bit too. If I have to go for like 5 hours tonight, I'm basically going to be wrapping up here and going to bed immediately, which isn't going to be the greatest. Okay, sorry for that little aside though. Saving and loading. Storing a game state to disk and then reloading it is not conceptually hard. You can imagine just taking all the data from our game and objects variables and writing them to a file value by value. It would, however, be a huge hassle that would require a ton of code. You'd need to define a way to structure the data in the file, and there's a good chance you'd get a lot of bugs at first. Luckily, there are ways of automating most of this that make saving and loading quite painless. Here's the teaser. And we have the save game function that save game and objects. They contain all our game state. Saving can fail, so return a result which should be okay or error. Convert both objects and game into JSON. Create a file called save game. That's where we'll write the game state. Write the JSONified game state to the file, and if nothing went wrong, okay, indicating success. Now there's a little secret in there, and if you've seen all of my coding streams, or if you know your Rust, there is something very popular in Rust called Serde, which means serialize and deserialize. The very first coding stream I did was a little bit of an overview of how I like to use Serde in some of my projects, and I've used it in a lot of my coding streams. A lot of my projects, if I want some kind of a config file or something like that, I use Serde because I find it very convenient and easy. So I can't help but notice we use Serde JSON. So we're going to go ahead and skip past this. We're not going to implement that yet because we don't have the dependencies and stuff. So let's keep going, and then we'll wrap back around and actually get the save game function working in due time. So it says, don't mind the question mark operator at the end of the line for now. It's there for error handling, and we'll explain it in a bit. The first line, Serde JSON to string and some data, takes the data we want to save, objects in the game state in our case, and turns it into a JSON encoded string. That functionality comes from these Serde and related crates, so we need to add them to our dependencies in the cargo.toml file, and we'll also enable the serialization feature in the tcod crate. All right, so let's actually do those now and get that set up. So first things first, I hope this still works. features equal serialization. I hope that doesn't get broken because we're using Git. We have rand. We need Saturday and Saturday JSON. So I'm going to use the versions they have here. Equal 1.0. Features equal derive. And then Saturday JSON equal 1.0. Here we are. So we're going to use those versions. We can actually go up to 1.0.144, but I'm going to stick with exactly what they have in case anything changed in the back end. I don't want it to break. Okay, so then, now that we have Saturday JSON and it won't completely make everything freak out, I'm going to say fn save game, and game, objects and object, and we're going to return a result. I could do the anyhow one here, but we're going to follow a little closer to what they do. I'm going to say let save data equals Saturday JSON to string and game objects. Now, what I didn't know is that you could actually do this with multiple things in a tuple. I guess, well, of course you can. It just takes any kind of data, basically. Why wouldn't it work with a tuple like this? Never tried it. I usually only feed it like a big config struct or something. File equal file, create, save game, file.writeAll, save data as bytes, and OK. And so far it's happy-ish. Doesn't seem to be resolving very well. We'll see what happens. It's having a hard time. We'll do a cargo build first. Failed to select a version for Saturday, which could resolve. What? Oh, I typoed. That's why. Womp womp. Yeah, I was like, why are you having trouble? Put an extra I in derive. Okay, yeah, and I was like, I didn't think it should be working right away. We'll import file. I know it's probably going to tell me to do that, but we'll import it. And it cannot find error. Import error. See, I never know which one it is. Error, okay. And then we got some other stuff to deal with. We need import write. I guess we're also going to need read. So we're going to need read and write. And so the only other thing remaining is that that's not serializable. So we'll deal with that in a moment. All right, we got a lot of stuff I just did, and I kind of jumped around a little bit. So let's back up here and take a look at it. So we got this save game function in place. We got our dependencies updated to take Saturday and Saturday JSON, and we added serialization on tcod. Now, why do we need to do that? Basically, what that tells me is that the tcod crate knows about Saturday, and it's like, yeah, everybody in Rust, they use Saturday for this stuff. And because we're a game engine, you might want to be able to serialize information about your game and save it. We're going to go ahead and implement the serialize and deserialize traits from Saturday. That way you can just save things to your disk, right? You can serialize and deserialize them. You don't have to worry about it. It's already done for you. So anyway, let's read a little bit more about Saturday. Yeah, so the functionality all comes from the Saturday and related crates. We add them in cargo.toml and we'll enable serialization. So we did that. The Saturday crate provides the main functionality for serializing and deserializing of Rust data. This includes the serialize and deserialize traits, which describe what to do for a given struct or enum or whatever. The optional derive feature provides a way to derive those traits so we don't need to implement them ourselves. And finally, Serde.json converts any serializable struct to and from JSON. If we wanted to use a different format, YAML, TOML, or anything else, we'd replace this crate with another one that supports what you want. And again, if you've watched my coding streams, you would have seen that I've done it with YAML, I've done it with TOML, I've done it with JSON, JSON 5. I think I've done it with other ones as well. I mean, you run into some issues depending on the formats. Like you can't do some things in TOML, like some of the enum related stuff. You can't do like ordered things in XML. So there are some limitations based on format. JSON and YAML can pretty much do whatever you want though. So they're very, very extensible. I kind of prefer YAML over JSON, but whatever. Anyway, now let's add those traits to our source code, including the save game function, and try to compile. So we need to bring in Serde's serialize and deserialize. I'm going to go ahead and do that in the background. We know we're going to fail because we could see down below. So I'm just going to go plop them in here, and then we'll worry about, we'll come back to the code in a moment because we know it's not going to work. Actually, okay, no, we're good. It's just saying unused, serialize and deserialize. So why is it failing? The compilation will fail. And it says here, the trait Serde serialize is not implemented. For what? For game. For game. It's down on the next line. Required because of the requirements of the impl for game. Okay, so pretty straightforward stuff here. What it's telling us exactly the problem, and then it's saying why we need it. That's all. So, and it's required by Serde JSON 2 string. So Rust error messages are pretty great. There's a good example of it, telling you exactly what went wrong and where and why and who wanted it and everything. So apparently we need to implement the serialize trait. It tells Rust how to encode each bit of data in our structs. We can do it manually, but it will be error prone and really tedious. Luckily, we can just use derive serialize and have Rust do it for us. So we're going to do it on the game struct. And it looks like that's going to bubble its way through our code a little bit. Just peeking ahead for that brief moment. Derive serialize. And now we see red because the trait bound tile serialize and messages and object. Basically, if you are serializing a struct, all of the components in that struct, all of the fields in that struct, map, messages, and inventory, all have to also be serializable. So what does that mean in this case? Well, map is a type that we made, which is just like a vector. So I would think that would be serializable on its own. But it has tiles in it, I think, doesn't it? Yeah, it has tiles in it, I think. That's probably why. Messages. We'll see what the problem with that was. I don't remember what all's in messages at this point. But then inventory, a vector of objects. That means object itself is also going to have to implement serialize. If we're going to be able to serialize an entire vector of them, we have to be able to serialize individual ones. So yeah, if you try to compile it, you'll see the complaint is shifted from game to object. We'll need to derive serialize for every struct and enum we'll be saving. There's a complementary trait called deserialize, which goes the other way from a serialized representation to a struct. So let's add them all at once. And yeah, we got a lot. So let's go ahead and we're back here on the code right now, aren't we? So serialize and deserialize. I like to put them in that order, but you know, maybe you're different. So we have game, and we have well, we already have some derives. We got to do it that way. Actually, we don't. I don't know if we need it on rect, do we? Maybe. Let's see who's complaining. Object. So struct object. And we'll say serialize, deserialize. And then that means like fighter and stuff need it. So where are they at? Yeah, there's the tile struct. Serialize, deserialize. Honestly, it's going to be easier to copy this. Yeah, the death callback is going to actually, if I do this, it's going to complain about death callback now. So there we go. Item is probably going to need it. Let's see who's complaining. Yeah, item doesn't have it. AI doesn't have it. So we'll do both of those because those all fit on the object, right? And who's complaining down here? Game, map, and messages. So let's go to the definition of messages. Derive. Boom. That one seems to work because color is already serializable because we brought in that trait. And then we need map. I don't know how we do this because it's a type like this. So can I do, whoops. Can I do derive like normal? If it's just a type like that? No. Okay, let's take a look at how map is done over there. Oh no, it's not map that's the issue, it's tile, excuse me. I was getting ahead of myself. It's tile. Struct tile. That's, I was like, ooh, that's gonna be funky. No, I was doing the wrong thing. Okay, so now we can derive everything, or we have derived everything. So let's come back over here. Let's break it down. We had to do it on messages, game, tile, object, fighter, death callback, AI, and item. Essentially everything that's being serialized or deserialized. Anything being saved to the disk or loaded from the disk, we need to implement that for. So it's a bit of a bother, but not the end of the world. After that, our code should be compiling, though it'll warn that save game is not actually called from anywhere. So let's fix that. Traditionally, roguelikes only let you save when you're quitting the game, so we'll call save game and play game right before the break that ends the game. Alrighty. So let's see. Why did you scroll? If player action, okay, there it is. So there's the break. Then we'll say save game, and it's just game and objects dot unwrap. I don't know how I feel about crashing the program if it fails to save. Maybe you'd want to warn the player that it couldn't save and then actually not break or something. Because then you quit the game, but you didn't save. So you just threw away the progress without a warning. That's, you know, whatever. We'll ignore that. Okay. So it says, if you run the game now and then quit it, you should see a new file called save game created. You can look inside it, thanks to it being JSON encoded. It's actually somewhat readable. It will contain all the objects in the entire game state. But if we're not able to do anything with the save file, what use does it have? We need to add a load game function too. Let's take a look. Let's go ahead and run it and see what we got. Cargo build, cargo run. No need for release. So we'll play a new game and we'll grab that item, and then I'll come kill a dude. I've taken some damage. There's a dead dude in here. You know, what'll be even more interesting is to have like a partially damaged enemy as well. Ooh, this dungeon is empty. Come on, bro. Someone come at me. Oh my god. Okay, there we go. So we're gonna do that. And the game, I already see the save file pop up. It's over here on the left-hand side in the Visual Studio Code window. So we're going to quit now. And I can open up save game. And it's a big old thing of JSON, right? Which formatter? All right, what's my default formatter? JSON language features. We'll do that one. It's good enough for me. All right. So here we are. We have the map, and the map is broken up into every individual tile, right? So what I can do is, if I wanted, I could cheat and I could actually find out information about the map I could find out information about the items and stuff. That's what I'd be most interested in. So not the map as much, but the if we wanted, we could add new messages to the game, which has no effect on the game. But if I wanted to cheat, I was like kind of hurt, right? So I have my inventory here, and I have a healing potion, another healing potion. I could just copy this here and add another healing potion. Interestingly enough, we actually still have an X and a Y coordinate for the potion that's in our inventory. That's where we picked it up, but it's not being changed, it's not being set or anything. It doesn't really matter. We have the player. We could change the player's character at this point in the save file, and it would actually load this back in once we make our load function. But see, that we have 17 health. We're kind of hurt, right? So what if I wanted to change that? I could totally cheat and change that value from 17 to something much larger. I could change my defense or my power. I could do a lot of cool stuff here. On death player, you definitely don't really want to change that much because that's the name of the enum variant, and it has to match, so you can't really do much with that. And then here's where I was saying is interesting though. We have the objects that are actually in the dungeon. So I know there's a lightning bolt scroll still in there. There's a an orc, another orc, right? So we can see all the stuff that's actually still sitting in the dungeon. Scroll of Confusion. So there is one on this spawn. Only one though. So that's cool. We can actually see how everything in the game just got saved to that file. And the file itself is... you won't be able to see this, but I'm going to reveal an Explorer. It is 185 kilobytes. It's a bit of a large-ish file due to the way we're saving. But, I mean, so what you could do, there are ways to actually compress certain things, especially when dealing with like maps and all that. We're not going to bother with it, but there are ways to do that if you care about file size and all that. It's not that big of a deal. Really, 185 is nothing. I've got like 12 terabytes in this machine, but I'm just saying in general, it's kind of a rather large save file considering the type of game we have and how simple it is. 185 kilobytes is a little impressive, I would say. Just personal opinion though. So we're gonna do the load game function because again, what use is it if you can make a save file but you can't load it, right? So load game is gonna be very similar. So it's fn load game, and it takes nothing, but we have a result of a game and a vec of object. Now this should hopefully look very familiar, because we've done something like this. When we made the new game function, it was a lot like this, right? So when we made the new game, or the one that like initializes everything. Let's see, where was it at? Yeah, the initialize. No, not initialize. FOV. The one that, yeah, this one here that gets us the game and the objects. It is new game. Okay. It gives us a game and a vec object. And guess what we just saved to the disk? We saved both of those things to the disk, game and the vec object. So it makes sense that that's what we're going to get back here, and that's what we care about for our actual load game function, right? So what do? We say let mute JSON save state equals string new. Let mute file open save game, and we're going to do the question operator there, so it just fails and bubbles up the error, and that's the purpose of the Boxstein error here. It says like, we don't know what exactly it's going to be. It's just going to be something that implements error, because it's a trait. File.read to string and mute JSON save state. Same thing there with the question mark, and then let result equals Saturday JSON from stir, and it's going to be We need the turbofish here. Game, vec, object. I do not type object correctly ever, do I? Go. Looks funky with the turbofish there, but it's okay. JSON save state. Bubble that up. Okay. Result. And it's never used. So we'll take a look back over here though. It's basically the reverse of save game. We read the save file contents to a string, then decode it into our objects vec and game struct, and if all succeeds, return the pair. In main menu, we'll handle the load game choice now. So let's go back to the main menu. Oh, it's right here. So that's nice. Nice and convenient, yes. And we had a choice remaining for that, which is going to be someone. Going to be load game. And let mute objects mute game equal load game dot unwrap. We just fail if it can't do it. Easy enough. Initialize FOV because now we've loaded a map in, so we have to do that. And game.map. And then play. I think I've typoed something somewhere. Or should map be? I guess it's fine. I didn't think it should be white like that, but I guess it's fine. And then we say play game on and mute objects and mute game. That's wrong. It's supposed to be tcod first. I don't know why theirs is different. So tcod. And then what's next? Game. And mute objects. Arguments are expected and mute game. Wait. What? No. Oh, they're in the wrong order. Mute objects in game. You know what? I'm writing it from the tutorial. They did that, not me. Okay, wait. We have tcod. Whoops. Expected game. Yeah, what do you want for initialize FOV? Because you're freaking out now. Let's take a look. It wants game. It wants a reference to game. There we go. Okay. Sorry. They have some oddities where they had them in a flipped order. They say mute objects in game, but the load game function says game and then object. Doesn't matter that much, but it's an inconsistency. And I don't like that. All right. So, and we can take a look at it here, where load game returns game and then vec object, but where they call it here, they say object and then game. A slight inconsistency, which breaks your code entirely if you're not careful. But, you know, the compiler is going to catch it. To make things compile, you'll have to derive deserialize to every struct in enum that has a serialized trait too, which we did. After that, you should be able to load a previously saved game and continue playing. But what if there is no game to load or the file gets corrupted? We haven't talked about error handling much, but now we need to. The Rust book has a whole chapter on error handling, so we'll only do a tiny introduction. You should read that chapter. Both save game and load game return a result value. Result is similar to option in that it has two possibilities it can return, one that usually indicates a success and the other failure. But in results case, the failure can have associated data as well. The successful variant's called OK and the failure is error. There's also the error trait, which represents an error and lets you get its textual description. All the file handling serialization errors in our save load code implement error. So looking at save game, the Saturday JSON to string call returns either OK string with the encoded value or error, or we'll say Saturday JSON error on failure. File create and the write all method works similarly, although with different success and error types. Since we can return more than one error type, we return box error instead. That lets us return any type that implements error, and the caller can get at the description and the raw error if they want. And then we have a link here to the Rust book, Recoverable Errors with the Result. We're not going to go through that now, but if you want to know more about it, definitely go check it out. One of the best things about Rust is the very explicit error handling. No exceptions or whatever, just very explicit. Bake it into a type and you can work with it. So the question mark operator is a convenient way of saying, if this failed, return from the function with error immediately, otherwise give me the success value. It's a bit like, this is me inserting some text here. It's a bit like the unwrap, except it doesn't crash the program, it bubbles up whatever happened. The operator also does an extra conversion to the error type specified in the function's return value. So let mute file equal file create save game question mark is almost equivalent to, and we have a match statement here. Let mute file equal match file create save game. Okay, and then we return this error here. The only difference is that the question operator also does a conversion of the error to whatever the error type calling function asks for. In our case, since we're using box error, no conversion will actually be done. So that explains the save load game functions, but what about using their results? Well, if you tried to compile the game, you've seen this warning. Cargo build, unused result, yeah, so let's take a look if I'm actually getting that. Cargo build, yeah. Unused variable on a tcod somewhere, but I'm not getting the result one, why not? AI confused doesn't need tcod. I am not sure why I'm not getting the unused. We'll keep reading and find out. Okay. So they're seeing it on the save game call. Did I just do it habitually or did they make another mistake? We'll see. So basically save game is not using the question mark and they're not doing anything else with it. So it's an unused result. So it warns, it complains. It did not cause an error, but Rust is being passive aggressive about how we're calling a function that can fail and then ignoring it. So we can keep ignoring it, try to actually handle the error, or simply crash by calling unwrap. Unwrap will make Rust happy that we've processed the result, but it will simply abort the program whenever we get error back. Replace the call to save game with save game objects game.unwrap. So let's find that call to save game in my code. Save game. We're already unwrapping it. That's why. Why? I feel like the further this goes, the more like minor typos there are, but they like add up over time, right? Anyway, you have to realize, however, that if this ever happens, it will make your users really unhappy. If save game fails for any reason, your game will just quit without any warning and the player will lose their progress. You should always try to handle errors gracefully. I feel like I said that already. Like I am speaking ahead of what's happening. Let's do that when we load the game. Calling load game right now uses unwrap as well, so if there's no game to load or something similar, we'll just quit the game. We could just print a message and let the player start a new game instead. All right, so let's take a look at that. And we're right at the end. So we'll also do this function to display messages as well. Because I don't want to click back and forth. So someone, that's our load game. And right now we have an unwrap on it. So what they've got it switching to is a match on load game. So we'll say match load game. We have the OK variant with mute game, mute objects. And we yoink this right up into there. Initialize FOV and play game. And the error variant is going to be what? We're not using it, but we'll do this message box. No saved game to load. Or and mute tcod.root. Continue. Expected expression on what? What did I do wrong? Oh, I see. I missed a comma after the 24. And I also missed the fat arrow. Okay, so then we'll need to actually display messages with that message box function, which is actually really short. Message box text, because we're doing something cheeky here. Watch this. And stir width I32 root and mute root. Let options and stir equal menu text options width root. Yep, so we are reusing our menu here, but we're basically not giving it any options. So there's not going to be anything to select. So it's just going to basically just tell us like a warning or whatever. That should be how it works. So click back over here. Yeah. Display messages. It relies on menu to do all the heavy lifting. And that's it. The actual saving and loading code was quite small, but we had to learn a ton of new stuff to understand it. So then if we clicked over to the next part, it'd be dungeon levels and character progression. And this is a big boy. Going to be a lot of code here. We're adding experience and stuff. So now all the fighters have to have experience, and I guess we're having levels at some point. Level up, experience. There's a lot going on here. So I think I am actually going to make us just wrap up here. I know that's weird. I was like, I'm going to go as long as it takes, but I'd rather not feel like I'm rushing it or feel like I'm forcing myself to do more than I need to. And it's going to be a lot to cram in at once. So I think this is a good place to settle down. I will commit, however, next time to doing all three of these. And they are a bit lengthy, but I'm okay with doing three lengthy-ish ones together versus like three of those plus the spells and ranged combat, which was already lengthy, plus the menu. Like it's actually going to be quite a bit. So yeah, we'll take a look at these two real quick. So just looking at the scroll. Oh wait, I'm on the wrong thing now. So just taking a look here. This is the next lesson. Take a look at that scroll bar on the side. And then the one after that is a little bit shorter because the scroll bar got longer. And then this one is way tinier. So it's a much longer lesson than the other two. So we'll see how it goes. But it's going to be cool. We're going to add dungeon levels and stuff. So it's going to get a little bit more variety. Variety level 51 or whatever. Okay. So we haven't actually seen how this works yet. So cargo build, cargo run, continue last game. Boom. We're back in there. Watch this. So I'm going to cheat. I'm going to cheat. 16 health? Nah. Wait. Oh, no, that's not me. Where's the player? We're going to cheat. We're going to say I have 30. I was like, I thought I had 17. Defense? 2 defense? Nah, I got 4 defense now. I got 10 power. I'm a one-shot everybody. So this is a very insecure way of handling some things because, well, look what we can do. So we'll continue the last game. Boom and boom. They can't even hurt me. Look at that. They're trying to attack me, but they can't. And that's the tough enemy. Ha! Bunch of losers. So, I mean, obviously that's not where you're meant to play the game. But hey, it shows that we can load the game. I even modified the JSON in the save file, and it still works. That's cool. But let's delete the save game now. Move that to the recycle bin. And continue last game. No save game to load. Look at that. That's a clever way to reuse the menu function. I like it. All right. So, as I said, that's going to be it for today. Here at a little over 3 hours. Kind of works out. I expected that these were going to be a little bit shorter. I expected about an hour or less per lesson, 45 minutes to an hour. And we only did 2 in a little over 3 hours. So this is why I'm going to go ahead and wrap up here. And I think we made good progress, though. It, on the one hand, it's like only 2 lessons, but we actually did quite a bit. The entire like whole spell system of like the scrolls and everything, the increased AI by the confusion scroll, basically letting us modify how the enemy AI works. That's pretty major. The way we can target things with the mouse and all that, that's pretty major. That can then be reused for ranged combat, like if you have a bow or something, or a crossbow or whatever. So that's cool. And then this huge refactor that made the game much more, not efficient, but it made the main a lot cleaner and made how we like start up and everything much cleaner, which then allowed us to save and load. So that was good. And that's pretty major, like saving and loading, the main menu, all that stuff. It feels more like a game now, right? It doesn't just start up and just die. 1 second. No, I was trying to get through, but I couldn't. It doesn't just start up and die. Like whenever we're done, like we quit and then, oh, the game's gone. We actually have a menu, so it feels a lot more legitimate. It feels a lot more real, which is always exciting, always fun. I like it. So let's just review one more time what we're going to be doing next time. For real, I think we've done enough to be able to comfortably finish next time with 3 parts. My nose is all weird now. I sound nasally. Sneezing is weird. Hold on. Okay, just had to like sniffle. I don't know if it really helped. But anyway, so next time we're going to do dungeon levels and character progression. Let the player venture deeper into the dungeon and grow stronger, including experience gain levels and raising stats. Part 12, monster and item progression. Deeper dungeon levels become increasingly more difficult. Here we create tools for dealing with chances and making them vary with level. In Part 13, adventure gear. Swords, shields, and other equipment can now help the player by granting hefty bonuses. The bonus system can also be used for all kinds of magics and buffs. Cool. So we got a lot of cool stuff on the way next time. Let's go ahead and just pull this up as a good closing screen so we can see the main menu as our progress, as our new state of game for the end of this 3rd stream of 4. I'm sure I will complete the other one in one session, the last 3 in one session. I don't see any reason I won't at this point. So yeah, that's going to be it. So as I always say, thank you to anyone who showed up to this stream, or if you're watching this on YouTube, I really do appreciate it. If you are new and you want to see more of this, you like this, go ahead and hit that follow button. I'd really appreciate it here on Twitch, but also if you're on YouTube watching this, please go ahead and do all the fun YouTube stuff. Lick that like button, kick that subscribe button and that notification bell. Leave me a comment. I especially, I do read all my comments, but especially in terms of programming stuff. Again, I say what I always say, that it's a little harder with a tutorial to provide constructive feedback or criticism because it's just someone else's tutorial, but in terms of how I present it or anything like that, that would be constructive and helpful, I would really appreciate that. I did take the little aside at the beginning to try to provide some context for that Mute2, not Mewtwo, not the Pokemon, but Mute2 function, and kind of what would motivate that and how you might do a little bit of problem solving to reach that solution rather than just, oh, it's in a tutorial, let's type it out. And that's the tough part that I've thought about as I'm doing these tutorials, is as I come across some code, I'm like, let me just write that out and explain what every line does, but that doesn't give us, again, the context of how we got to those lines. So there may be a little bit lost there, and I don't think that's necessarily a problem with what I'm doing. I think it's a problem with tutorials in general. Nothing against this tutorial, but I think a lot of tutorials they struggle with that, because it's hard to do that without becoming too verbose and not getting to the point, basically. So I don't know. It's something that I hope that was helpful at the beginning, and You know, it was very unscripted or whatever, but it hopefully provided some good context to get us, you know, thinking about like solutions and problem solving, which is really what code is. Code is find a problem and then find a way to solve it. And when you're making a game, your objective is to basically create more problems, right? Because those problems are features, right? So the next problem is, well, like experience and stuff, right? That's our problem. We're going to be dealing with like leveling up and experience and all that. So that we need to come up with a solution for that. So there's going to be more like involved stats and everything, or the stats are going to be changing as we level up. So there's going to be a lot of interesting stuff there that is presented as the solution to the problem, which is, you know, our player is really static and generic and doesn't change as we kill monsters. So let's make them level up and everything. You know, that's one way to think about it, right? Features in a game are basically solutions to problems, if you want to think of it that way. So yeah, I hope that was helpful. I know I'm rambling on a bit. I'm going to go ahead and wrap up. As I already said, thank you to anyone who showed up, do all the fun follows and likes and all that good stuff. It's all free. And I will say I'll do the other part of my normal outro that I stream like every day unless I'm just feeling awful or something. Mondays and Wednesdays are coding streams. Every other day is gameplay. But I might also squeak an extra coding stream in before Monday just to wrap this up. Not in a way to rush it, but also just so I can kind of start that other one on Monday fresh. Start the other roguelike tutorial. So if there's time, I might try to squeeze these in on Sunday night. That would be my anticipated extra coding stream would be Sunday night, which only matters to anyone listening right now on the stream, because by the time this is up on YouTube, it don't matter. Alrighty though. So enough of me rambling. Until next time, have a good day, have a good night, whatever it is, wherever you're at, take it easy.